On February 25, 1996, on Space Shuttle mission number STS-75, NASA launched a possible breakthrough energy technology experiment. They launched a 12-mile-long electrical conductor cable called an electrodynamic tether, designed to collect high-energy electrons in the Earth's ionosphere and magnetic fields. The motion of the conductor tether across the Earth's magnetic fields induces a voltage along the 12-mile length of the tether. Utilizing estimates in the charge densities of the Earth's magnetic fields and the ionosphere, the voltage produced is expected to be up to several hundred volts per kilometer. If successful, the experiment could produce a lot of electrical power. If additional power is driven along the tether in the opposite direction to that which it normally wants to flow, the tether, in theory, could push, creating propulsion against the Earth's gravity to raise the shuttle's orbit. The advantage to this revolutionary technology in propulsion is that it does not require any rocket fuel. If successful, electrodynamic tethers could prove a way to greatly reduce the cost of in-space propulsion. For example, the International Space Station could keep itself in orbit, saving nearly $2 billion in orbital reboost rocket fuel for every 10 years of the station's operations. But on February 25th, after the 12-mile tether began producing electricity, an unexpected overload of electrical energy fluctuating between 2 and 10 times that predicted, due to inaccurate estimates in the electrical charge of the Earth's magnetic fields, ionosphere, and possibly space radiation, fried the tether conductor cable and it broke, severing it from the space shuttle.
So the tether has broken at the boom. The tether has broken and is going away from us. Get it on the TV, Claude. Please get it on the TV. The tether has broken.
Copy.
Columbia and the satellite now 77 nautical miles apart. Again, that call reporting that the crew can see the tether and see the satellite. It's beautiful. This view showing the satellite. Again, just moving into sunrise. 81 nautical miles now from Columbia.
Guys getting the image?
Franklin, we see a long line, a couple of star-like things, and a lot of things swimming in the foreground. Can you describe what you're seeing?
Well, the long line is a tether, and there's a little bit of debris that kind of flies with us, and it's illuminated by the sun at such low angles. So there's a lot of stray light, and is getting washed out quickly, but Claude is trying to do a quick, good job here adjusting the cameras.
Copy that.
You know, that description by the crew, this is the tether in the satellite with approximately 12 miles of tether still attached to it. Columbia and the satellite now just passing over the west coast of northern Africa. The two spacecraft now 90 nautical miles apart. Controllers for the satellite did have communications with it during the close pass between Columbia and the satellite.
Columbia, Houston, that's a much better view, a lot more contrast visible. And how wide does that tether appear to be? It seems to resemble a much wider strand than we'd expect. Can you describe which way the satellite is visible on that strand?
Satellite now 100 nautical miles.
Charlie, completely unzoomed, and you see the full extent of the tether. I tried to adjust the focus, but I can't get better than that.
Okay, Claude. Thank you.
I'm going to zoom in now.